A couple of weeks ago we looked at identifying understeer in the Race Studio 3 data, and you remember that we looked at this metric rotation degrees per meter, which was a maths channel that I built. So we see that just here, and we compare that to the steering angle. So what we're looking at here is how quickly is the car rotating compared to the amount of steering that I'm putting in. Now what we saw was that in an understeer condition you put in more steering angle, but the rotation either doesn't increase at all or actually starts to drop away. So I'll drop a link here to that previous video, and I strongly recommend you go and look at that first before watching this one, because there are some concepts in there that I'm not going to cover again. Okay, so this time we're looking at oversteer. I'll show you, let's just step through this one particular, we'll step through this one particular corner. If you watch the video on the right hand side just initially, so we're coming up to a hairpin called Wilson. I turn in, and yeah, the car goes completely sideways. And yeah, it was at a recent track day and it was a damp track, and you know, that's my excuse anyway. So as we can see here, if we look at the rotation degrees per meter, so that's the amount of rotation we're getting in the car versus the steering, it all looks good initially. And I noticed actually in the understeer video, you notice that occasionally we seem to get this sort of, I wouldn't call it a spike, but you get this quite sharp increase in rotation, and I think that's oversteer on turn-in. So the back is just coming round a little bit as we turn the car in into the corner, and then we're holding the steering pretty much steady, and you can see that we're getting some understeer. So the grip is dropping away, we're not getting much rotation, and then I actually start to unwind the steering as we go around the corner. So we're unwinding the steering, and then that keeps, it looks okay until we get to this point here, where suddenly the car starts to rotate rapidly, and now I'm going to attempt to counter steer, you know, opposite lock type steering. I just want to drop a quick note in here, something I didn't cover. So why is it suddenly oversteering in this way? I suspect what's happened is I've crossed the dry racing line, and it's the combination of the wet and the rubber on the dry line that's made it very slippery, and that's why suddenly I've started to get oversteer. The in-car video you see here slightly lags the data, which I think I pointed out in the other YouTube video. I had some really good feedback on my understeer video from Mark and from Matthew, and I'm just going to cover Matthew's point first. So what Matthew said was it would be really good if you showed real steer angle rather than an absolute value. And at first I thought, I'm not sure I want to do that, but this is a good case in point where you might want to consider the real steer angle versus absolute. Absolute just means that if the steering angle goes negative, it just converts it to a positive number. Now if you look at the white plot here in this trace here, it looks as though I'm turning into the corner even harder. But in fact, if you watch the video, what I'm actually doing is dialing in loads of opposite lock to try and counter the oversteer. So this is an occasion where you've got to be aware of the context when you're looking at the steer angle value. Now, as he said, if I put in the absolute steer angle, so we could probably do that quite quickly. Let's do that. 400 degrees of absolute steering. There's quite a lot of opposite lock. This is going to be even more confusing, and I'll explain why in a minute. Let me put a different colour on that. Okay, now you see the absolute steer angle. Now the first thing you notice is it's going the opposite way to the way the steer angle went when I steered into the corner. And that's because in my car, a right turn produces a negative steer angle. And of course I've used the absolute value, which has converted it to a positive. That's the white plot. So you can see they're the opposite way round. But what it also shows you is that then I shoved in a lot of negative left-hand steer, and that's why the purple plot then goes the other direction. So not quite as easy to understand as I'd hoped, but you can see Matthew's point here that you know, if you want to know which way you're turning the steering, you can't use the absolute value. So I think he has a point. I'm going to have a think about whether I want to switch to using this way, because there are some disadvantages with not using an absolute value, particularly when you're looking at understeer. Actually, in an understeer condition, you don't very often turn the car completely the opposite, you know, to the opposite lock or the opposite direction of steering. Although my friend Antonio was telling me that he does that sometimes to get grip back when you've got severe understeer, which is quite true. If it's severely understeering and you've got enough space on the track, then turning away from the steer, you know, turning away from the direction you want to go, actually does bring the grip back. So I can see how you would sometimes use it, but it's less common than it is in an oversteer condition. Okay, let's take that away again. We'll move on to look at something more subtle rather than this extreme version of oversteer. But before we do that, I wanted to cover the other point that Mark raised in his feedback on, this was through a Facebook group. What he said was, and he's a professional vehicle dynamicist, as far as I can make out, and what he said is, the way to view it is lateral force, or cornering force as he called it, versus steering angle. So for cornering force we can substitute lateral acceleration. So I wanted to look at that, and in fact I already do look at that in a different way. So let me show you how I would normally look at that. So let's start with a complete lap, and let's look at this scatter plot. We've got some extremes out here. This is the oversteer we were just looking at. Let's change the lap so we haven't got that. Okay, there we go. Now, if you imagine a straight line that starts about here and goes straight up, straight up, straight up through there, straight up through there, that would be a linear relationship between steering angle and lateral acceleration. And you can see that in the main, most of the points fall along that line. I know there's some deviation, but actually it's pretty linear nearly all the way. But then down here, you get to the point where you are cranking in more steering angle, but the acceleration is not changing or is not increasing. Now these are, you know, we said about right-hand corners are produce negative steering angles, and the acceleration in right-hand corners is a negative value. But what you can see is that the value is not increasing. We're increasing the steering angle, but the value is not increasing, and that there is understeer. Similarly, on a left-hand turn, you've got increasing steering angle, and you're not getting any increase in lateral acceleration. And this is what Mark was talking about. He was talking about the fact that you can use this cornering force or lateral acceleration against steering angle, and you can identify understeer. Now the problem with this was that, or the problem with this is that it's really difficult to look at this as you're going along a track. You can do it, because if you look, let me find it, there it is. There's a little crosshair thing here. And if we go back to a corner like Wilson, which is a sharp right-hander, you can move through these plots and see that you're getting understeer at this point here, and so you can actually visualize it, and you can visualize it down here in this little graph. But you do need to, if you're going to do it as steering angle versus, lateral acceleration versus steering angle, then you're going to have to do something like divide one by the other to give you it, so that you can look at it in what's called a distance domain. So you can look at it as a straight plot against distance like you have here. The problem with this plot is this is just the lateral acceleration. It doesn't take into account how much steer angle you've got in. And if you look in my original time distance plot, I've already got that value in there, which is here. I've got an absolute version of it, but that's basically what this is. So I added a maths value, a maths channel, which I've called understeer, oversteer, or UOS, where I've taken, I'll show you the maths channel. So I've gone 100 times the acceleration divided by the steer angle, and then I plotted that. Now, I don't know if I've done something wrong here, but if we go back to look at that thing at Wilson, change the lap again. I'm getting more, I think these must be noise spikes in the lateral acceleration. You don't see them here because I've got this set to have a rolling average, but I think these must be noise spikes. And actually at the point where the problem occurs, where the oversteer occurs, what you see is, actually you see exactly what he said you'd see in his post, which was you'll see an increase and then it will drop away, which is what it's doing there. But that's quite subtle. I could make it look even bigger if I multiplied the G value by 1,000, let's say. Maybe that would give me a bit more contrast. But I'm a bit worried about this stuff. I could probably average it out to get rid of the noise. So I think this could be useful. In fact, well, it is useful, isn't it? Because when you look at it in the scatter plot, it actually is pretty good. It's showing you pretty much exactly what's happening. This one looks weird because this is where I've got a massive amount of oversteer. That's why you've got this thing going right out here. That's me cranking in loads of opposite lock. And we're still, even though I've cranked in loads of opposite lock, look, the negative turn is still high. With me turning in completely the opposite direction, so that's a very big oversteer condition. We do use this in this scatter area. Could we use it in the time distance? I think I'll have to play with it some more to find out if I can, but it's worth looking at. Whilst this is all very interesting, what we need is something that we can actually take away from this and apply on the track. And it's, I've used this term, so what? You apply the principle of so what? So what if it has got these spikes in it? What does that do for me? And you're right to ask. What we should be doing is coming up with something that says, when you see this happen, what you should do is do this, do something else. So that's what I want to try to do. It's going to take more analysis. Let's not dwell on this any further. Let's move on and look at a more subtle oversteer condition. Okay, this time the track is Brands Hatch Indy and the corner is Druids, which is a hairpin, which you can see down here on the sort of over, the satellite view. Right, so we're coming into the corner now. You'll notice as we go into this, well, a couple of things. My braking profile's not great, but one of the things I do is trail brake very deep into the corner. So you can see I'm holding the brakes all the way into the apex, and if you look at the rotation, even though I'm not increasing the steering, in fact I'm slightly unwinding it, the rotation is increasing, and that's because I'm trail braking very deep into the corner. Now, I would say that's good, In fact, that's what my driving coach has told me to do. So I think this is pretty good, except for I probably should have trail braked a little bit further and not got on the accelerator so quickly. So if we watch, the rotation starts to drop away, and now to get round the corner I'm having to crank in loads of steering angle. Look at the video on the right. That's not great, I would say. I mean, this is a very tight hairpin, but this is sort of at this point what's happening is in fact you can see actually it switched from oversteer to understeer. Basically that's what's happened here. And because if you look here, as we lose the understeer, the rotation angle pretty much follows the line of the steering angle. And it's, while I've been producing these videos, not just this one but the understeer one, I've realised that I've got a really bad fault with my driving style, and that is that I lean on the understeer. I use it a lot, which is really bad. I mean, I get away with it because, of course, as you're understeering, you're scrubbing speed, and then it grips up, and then you get the turn. But I'm losing too much speed. It's just crazy. So I need to have a really serious think about my driving style around tight corners, because I don't think this is good. It's not just at this corner. I've caught myself doing it in videos in loads of places on various tracks. So that's definitely an improvement note for me, and that just shows you what you can achieve with analysing this sort of data. Anyway, I hope this one's a bit less obvious than the previous one where the track was damp, etc. This one is, we're in the middle of a race, I'm chasing this guy in front, I'm pushing as hard as I can, but possibly a bit too eager to get round this corner, got on the throttle a bit too early, came off the brakes a bit too early, and the result is it's flipped from oversteer to understeer, and now I'm losing speed, because basically I'm just scrubbing speed as I'm trying to wind in all this steering angle. Eventually, as I open the steering out, you see it grips back up, and we're back to, I would say that angle there is probably okay. It's just what I shouldn't have done is that one. Okay, well, I hope you found this interesting, and I'll catch you on the next one.